Okay, so we went over average velocity and we got our average velocity for V1, which is the difference in displacement over the difference in time. 3/2 is 1.5 meters squared, meters per second, I'm sorry. V1 is 1.5 meters per second. And then V2 is 2 meters over 2 seconds, which is 1 meter per second. And so that's how we get the average velocity. I think at the end of the last video, I actually said it was 1.2, but it's V1 is 1.5, 3/2, and V2 is 1 meter per second, which is 2 meters over 2 seconds. Okay, so the next thing we want to do is acceleration. And acceleration is really important for physics, and it is the difference in velocity over the difference in time. So it's going to be acceleration is delta V over delta T. So the first thing we want to do is find delta V. So we'll draw delta here. That'll be delta V. And that's going to be V2 over V1, or V2 minus V1. And so that's going to be delta V, and we'll say this is delta V 2 to 1, 1 to 2. The difference in velocity from 1 to 2 is V2 minus V1, which is V2 is 1 meter per second minus 1.5 meter per second equals negative half a meter per second. So that's our delta V, V1 to V2. So we want to find our acceleration, and we're going to be finding it at this point. So that's going to be A1 there. We'll do A1 to 2. So that's the acceleration between V1 and V2. So A is going to equal delta, draw delta. V over delta T. Okay, so that's going to equal V2 minus V1, like we have here, over delta T, which is T2 minus T1. So we know this is negative 0.5 meter per second is V2 minus V1, delta V, and then delta T is 2 seconds, 4 minus 2, and we know that from before. So I'm just going to put a 2 there, 2 seconds. And so 5 minus, or divided by 2 is 2.5. So 0.5 divided by 2 is 0.25. So 0.025, or 0, negative 0.25 meters per second squared. Okay. And okay, so hopefully that fits on there. Okay, great. So that's our acceleration at this point. It's negative because the difference in velocity is negative. So we'll take this a little bit further, and we'll go one more point. So we'll do T3. So this is going to be T3. And that point there. And so X. So we'll just round up and say that's going to be 1. So let's see if we can. move that there. Okay, so this will be x3. Okay, so what we'll do is we'll find the acceleration at this point. So 1 to 2 was at this point here. And so we'll find the acceleration here. So that'll be a2 to 3. a2, 3, right here. And so that's going to be our average velocity there. It's going to be there. Okay, so that is v3, which is from 2 to 3. And we can just count this off here. So that's going to be, we know this is 5 here. 1, 2, 1, 2, 3, 4, 5. And that's 1, so that's 4. So V3 here. V3 is equal to x3, which is 1, minus x2, which is 5. And I'll write out this equation, and then t3 minus t2, and it's going to be 2 seconds again. So t3 minus t2 is there, equals, and we know this is going to be, I'll write this out. We know x3 is 1, x2 is 5, divided by, this is 6 minus 4. Okay, so what that equals is, and this is in meters per second, so that's -4 meters divided by 2 seconds. 6 minus 4 is 2. And so then that equals 4 divided by 2 is -2 meters per second. Okay, so what it is it's going in the negative x direction in 2 meters per second. So that's v3. So if we want to find the acceleration at this point, that's going to be the difference between v3 and v2. So we say the acceleration from 2 to 3 is equal to v3 minus v2 divided by t3 minus t2 and that's equal to v3 is -2, v2 is 1 meter per second, and so that's meters per second, 1 meter per second. And then we need to divide by the difference in time. So same as here, that's 6 seconds minus 4 seconds. And that's 2 again. And so -2 minus -3 is -3 meters per second. And then we need to divide by 2 seconds. And 3 divided by 2 is -1.5 meters per second squared. Okay, hopefully that fits on there too. Great, so that is our acceleration at this point is going to be negative negative 1.5 meters per second. Okay, so one thing we can do is we can graph the velocity. So I'll go ahead and draw another graph here. This is going to be v of t. Okay, so this is a velocity is a function of time as well. And this is t here. And we'll go ahead and draw this out. So it'll be 1, 2, 3, 4. And this velocity is in meters per second, and this is seconds. And we'll track the same, we'll do the time on the same scale as the position above. Okay, so these are still T1, T2, T3. Okay, so we can just, it's pretty much this simple, and I'll make a dot and connect the dots. So we know that it's 1.5 at T1, V1 at T1 is 1.5. This is 1 and 2, so I'll do one that's a little, like a half there. I know at T2 it's 1, so we'll do it there. I'll go ahead and do these lines here. And so here we know it's -2, so I'll have to extend this down. Okay, so we'll say that's 2 there. Actually, I'll write this, so that's 2 there. And so that's -2. And I'll draw corresponding lines. So it's actually more like here. And I can put that above the axis so we can see it's clear there. Okay, so assuming we start at rest, v equals 0 at T1 we're 1.5, at T2 we're 1, and then for T3 we're at -2. So that's how the velocity goes. You can see here, even though the position is increasing, the velocity is actually decreasing there. And then it switches and goes negative. So this is our graph for velocity, and we can also make one for acceleration, but I'll wait and do that another time. So these lessons, the coordinates, position, velocity, position, time, velocity, and acceleration, and the basics of these quantities of motion are covered in the first 4 sections of chapter 2 of the textbook. And so we pretty much should have covered those. I might go through the textbook and just flip through it and share it as a video and make sure we've covered all that in case you have any questions. And I'll cover the equations of motion, kinematics, and gravity, and that type of acceleration, and for the second half of chapter 2 in another video. So this is going to be good for now, and I'll share more videos with you in the future. And I'll also go over some of the problems in the problem set, especially the first one, so you can get started solving those problems. Okay, thank you.